This is the world today. We're riding a wave of technology that's changing everything. From how we communicate and share, to how we bank, educate ourselves, see a doctor, grow food, share culture, and otherwise live our lives. And it's only getting faster. Keeping up takes more than the newest hardware and software. It takes people. People with the expertise that comes from helping tens of thousands of companies worldwide adapt, transform, and grow. Experts at using innovation, analytics, and automation to deliver predictive services that solve problems before they impact your business, to help you seize every opportunity. It takes Cisco Services, a hidden force behind over 80% of the world's largest companies, as well as organizations with big ambitions. We foster innovation and deliver excellence. We are expert advisors, simplifiers, implementers, optimizers, and managers. Security, networking, data center, multi-cloud, unified communications, and IoT. We are here with you. No matter where you are around the globe, we are ready to help you do the one thing most essential to your success: to accelerate. Cisco Services. Accelerate.
It can detect a threat using AI and respond 60 times faster. It lets you know where your data lives down to the very server. It keeps your insights from prying eyes so they're used by no one else but you. It is the cloud. The IBM Cloud. The cloud that's built for your business, designed for your data. Secure to the core. The IBM Cloud is the cloud for enterprise, yours.
Ladies and gentlemen, our program is about to begin. As a courtesy to our presenters, please silence all mobile devices. Thank you. Ladies and gentlemen, our program will begin shortly. Please take your seats and silence your devices. Ladies and gentlemen, please welcome from VentureBeat, Stuart Rogers.
Good day. Good day, good day, good day, good day, good day. Hello, everybody. Welcome to Berkeley. That's not how a UK person normally pronounces that name. I had to learn that. Berkeley instead of Barclay. It's a crazy thing. Welcome, welcome, welcome to VB Summit 2017. It's amazing to see you all here. Thank you so, so much. We have an incredible program coming up for you. We've got amazing speakers. We have just so much in terms of value, in terms of takeaways, in terms of case studies, in terms of everything that you need to understand the world of artificial intelligence and ride that wave. But before we get into all of that, we have some housekeeping notes that I have to read out for you, because that is my job. That's what I have to do. So, without further ado, we shall, if the clicker works, thank you. First of all, thank our sponsors. We would like to thank IBM and Indeed Prime, TomTom Maps, Cisco, Personali, WellPay, Switch, Orange Silicon Valley, Outside Insight, and University of Nevada, Reno. Thank them so much for their support of this incredible event. And we want you to have an amazing Wi-Fi experience. It's very, very important for us to do that. So you want to go to Fairmont_meeting, and the password, we made it nice and easy for you. It's just VBS 2017, all lowercase. That will get you onto the Wi-Fi. It's fantastic Wi-Fi. It's the best for things like email, for example, and messaging. But please don't be streaming House of Cards on Netflix on there, because that probably will kill it at some point. We also want to make sure that you tell everybody about this event. We actually had a team of 10 people spend 5 hours coming up with hashtag VBSummitAI. So please use it, because otherwise those people's time would have been wasted completely. So use hashtag VBSummitAI. You can use that everywhere that you can use a hashtag. You can even use it in places that you can't use a hashtag, like in Snapchat. In fact, if you share stuff through Snapchat today, their share price might go up. You can also stream live. Everybody is streaming this live. Welcome to all the people who are streaming on Facebook, facebook.com/VentureBeat. It's awesome that we're doing that, and that means that we're extending the reach of this incredible content out to the wide, wide world. We want to make sure also that you join us at our upcoming events. We have Blueprint, which is in Reno in March 6th, 7th, 2018. We have GamesBeat coming up April 9th and 10th, 2018. And we have MobileBeat in July 2018 and VB Summit again in October 2018. So please make sure that you look at venturebeat.com/events. That's where you'll find the latest and greatest information on those. And we'll remind you about all of this again tomorrow, of course. So, on to the program, and it gives me great, great pleasure to welcome on stage, to set the scene for you and start the day, the CEO and founder of VentureBeat. Please give Matt Marshall a warm welcome.
Thanks, Stuart, for the warm welcome. Welcome, everybody, to VentureBeat 2017 VentureBeat Summit. So this is the first time we're doing the VentureBeat Summit. It's previously been called the Mobile Summit. We have been doing that for 8 years, and we've changed it this year to be able to focus on the trend of the day, and that is indisputably AI, right? So I am a busy guy. So I've got a 1-year-old, I've got a 3-year-old at home, and so I bought the Alexa Echo. Right? I thought it was going to make my life a lot easier. And I like the Echo, but I find myself shouting at it occasionally, trying to figure out if I can understand my words or it understands my commands. And I somehow keep trying, and I think it's actually going to adjust to me over time. So I have some faith that it's going to happen. So why do I start with that fumbling example? Well, I think the reason is because it's early, right? The experience with the Alexa is kind of a cliche example of what consumers are engaging with AI on. But in business, too, it's very early. It feels like there's a lot of pain and we're struggling. But at the same time, the conversations I've had over the last year have led me to believe that this is going to make or break companies, right? That it is already making a change, and it's worth starting to look at AI right now. Back to that Echo example, right? So for every 3 or 4 commands that I shout at it with my voice incessantly growing impatiently, I do make that breakthrough. I finally get it to show Mr. Blippi's toothpaste video, from my favorite 3-year-old son video to do his toothpaste in the evening, to brush his teeth. But seriously, it is time to actually take this seriously. It's an example. The machine's learning, the human's learning, and what we're doing today is starting off after hundreds of conversations with applicants that are coming to, wanting to speak here. We had more than that in emails where we were looking for real cases of AI. And not only AI in implementation, but they're actually getting real results. Right? So what happened more often than not is we would be talking to a company, and it would actually dissolve. It wasn't either AI or it was hyped. It didn't seem cracked up to all of what it was. So we kept looking, and sure enough, occasionally we found companies that were doing mind-blowing things. Right? So you're going to be hearing about those things over the next 24 hours. Right? Google implemented in 9 months a step function improvement in Google Translate. That's made more improvements in 9 months than over the previous 10 years. Right? We're going to be hearing about changes across the economy, right? As mobile sensors have combined with research and compute power to make changes all over the economy. So changes in hiring practice and real estate, right? We're going to hear from Zillow, which is making the Zestimate ever more accurate. But LinkedIn has improved 20 to 30% things on the order of recommendations, job applications, or engagement in the feed. We're going to hear from Autodesk, which has decreased the cost of customer call service calls in some cases by 90%. So a lot of these companies have been trying a long time, and they have been working at it. So it's important to remind ourselves that it's worth persisting because you will get results. Wanted to say something about what this event is not. It's not a nuts and bolts event where we're not talking about how to do AI, right? Or the ABCs or the 101s, 102s that you can get at any number of events. And it's not a research event. What we did specifically here today and tomorrow is to call for real cases that inspire you, that can show that it can be done, and real cases that are getting results. So at the same time, we also want to bring some humility to it, right? So we do have some thought leaders here, and they're going to be leading most of the sessions. But at the same time, we have a session tomorrow, the boardroom sessions, where we go for a whole hour where people can come and actually ask questions during that hour from these thought leaders and actually contribute their own findings and their own struggles. So we hope you'll get a lot of use from that. And I want to echo Tim O'Reilly, who just published a book. Just curious, how many of you have finished reading that book, WTF, right? What's the future? Or it's a euphemism for another expression. Okay, nobody. All right, so he talked about, it's worth talking about then, right? Talking about massive unicorn opportunities that are being afforded by machine learning today, right? And that have big social impact opportunities. But it's up to us as we push it forward to make sure that it's with positive intentions. So what better place to start than with a man who started 25 years ago in his college thesis talking about creating an artificial brain, and then had to kind of drop it because maybe that field wasn't considered really current. But then 6, 7 years ago came back and started picking this up again, and neural nets became popular again, and he started introducing it to all these different products in Google. And then provoked Google to actually come up with the infrastructure, software and hardware, to make it possible. Right? And actually, the Google CEO, Sundar Pichai, recently said Google is an AI-first company. So it's part of this man's work that has made that happen at Google. So please welcome Google Senior Fellow, Jeff Dean. Jeff, hi, welcome. Thanks for joining us.
Thanks for having me.
I feel overdressed in this suit. If I was in Mountain View, I'd have a T-shirt.
So would I. So would I.
So Jeff, thanks for joining us. You have implemented neural nets in all kinds of products. You've talked about maybe, I think I saw one slide with thousands of projects that are implementing this across the organization. But Google Ads, Search, Translate, Maps. Can you talk about, since we're focused on results, can you talk about specifically some of the areas that are getting the most traction right now in neural nets?
Sure. I mean, I think that one of the things about neural nets is they're these really powerful abstraction tools where you can kind of learn any sort of complicated function from input data, which could be sort of raw things like pixels of an image or an audio waveform or a bunch of text, to produce outputs of things that you care about, things that you want to learn from those low-level inputs. And so that means it's a very general technique that can be used in many, many places, all across Google products, all across lots and lots of business applications around the world, and so on. And I think one of the things that is true is that really deep learning is causing this revolution because it has this really powerful sort of fundamental building block that you can sort of wire it up to do lots and lots of different things. So here's a couple of graphs that just illustrate kind of the exponential growth in interest. The first one is interest in the term deep learning, which is maybe not quite so interesting since deep learning is a relatively new term for the notion of artificial neural networks, which have actually been around since the 80s, 70s even, and were sort of first popularized and were really interesting in the 80s and 90s, but we just kind of lacked enough computational power to really make them sing. Yeah. And now we have that, and so they're really doing powerful things. And the second is a graph of how many machine learning research papers are posted on arXiv, which is a sort of research paper posting service, and you can see that they're growing by a factor of more than 2x every 2 years. Which is pretty substantial, growing in interest in community. One of the things that I think is interesting is, as I said, you can use them as these flexible tools that can do all kinds of different things. Yeah. So here's some examples of functions that a neural net can learn. You can take in an image and produce a category of what is in that image. Is it a lion or an octopus or a garbage truck or an aircraft carrier? Simply by training on lots of observations of images and labels that people have assigned to those images. You can do audio, so you can do speech recognition for your phone or your devices like Echo or Google Home. You can do translation, as I'll discuss a bit more, but essentially you can take in a sequence of words, one word at a time in English, and learn to produce the corresponding sentence that means the same thing in French or German or Spanish.
So Jeff, one of your slides, I'm sure you'll get to it. We could go back and forth if you like. Just struck me by how many projects at Google, literally in the thousands, are implementing, I think, neural nets, right? Mm-hmm. Not only not only deep, but just neural nets. I think most of us are thinking, yep, audio, we get that, translation. Image recognition, there's a few kind of higher level categories you've implemented this. You haven't talked too much publicly about the extent to which all of your products are being influenced by this. Maybe we could start the other way for the people in the room that are coming from these other industries. Is there any industry that won't be impacted specifically by neural nets over, say, the next 1 to 2 years?
So I think, obviously different industries will be impacted at different rates, but these techniques are really pretty fundamental. And are really going to affect lots and lots of industries, not just sort of computer science-oriented things, but more broadly, pretty much any industry that operates with data is going to be wanting to think about how they can use machine learning in their tasks. As just a simple example, if you think about computer vision and how much it's improved in the past 5 years due to the use of deep learning, in 2011, the winning entry at the ImageNet contest, which is a contest hosted by Stanford, did not use deep neural nets. It was just a year before that sort of really became practical, and that got 26% error. And we know human error on this task is 5%. So really, in 2011, you couldn't really do computer vision very well. Now, the winning entry in 2016 got 3% error. So that's really a fundamental change in what you think about in terms of computer vision. Computers can now see, and they couldn't see before. And that has big implications for all kinds of things. Lots of business processes you'd like to be able to identify, is this part broken on my assembly line? Or does my windmill look broken? Or is the train coming into the station now? Or are there lots of cars waiting at the stoplight with a red light?
Yeah. So you won't talk publicly. Obviously, your PR team won't let you talk specifically about ad product. It's extremely competitive. There's a large ad industry there. But there are people dependent on the ad industry in the audience. There's service providers that are interested in optimizing sales, right? There's marketing engagement providers here as well, and there's brands that are looking for ways to improve engagement, retention, and so on. Can you talk a little bit about what they should they be implementing neural nets in 2018, or is it early for most people, right?
Well, I think I would characterize it as if you have interesting amounts of data. So one of the drawbacks of neural nets is they tend to be fairly data hungry.
Yeah.
But if you are in the situation where you actually have a fair amount of data that allows you to have set up a supervised problem of going from some input data to something you care about from that input data.
Yeah.
So maybe it's like a bunch of customers and their actions on a site, or their behavior, and then you want to predict which customers are likely to be buying an airplane ticket in the next month. That's an example of something where deep learning with enough data will do a really good job. And so anything where you can kind of model those sorts of sequences and then have either a low-level prediction or some high-level sort of task you're trying to model, I think is something you should definitely be looking at.
So it's a game of scale. You have data, so you'd probably be looking, I know you're not an economist, but looking at consolidation in the industry. You'd think if you're gonna beat the market using some of this data, using neural nets, right? You're gonna have to get more data. Let's take a look at your typical retail brand. Let's Sephora, right, or maybe a Walgreens. Do they have scale that's necessary for using neural nets in some of their, say, customer engagement tactics?
I mean, I would say pretty much any business that has tens or hundreds of thousands of customer interactions has enough scale to start thinking about using these sorts of things.
Okay.
If you only have sort of 10 examples of something, it's going to be hard to make deep learning work. But if you have 100,000 kinds of things you care about, input records or whatever, that's the kind of scale where you should really start thinking about these kinds of techniques.
Great. Okay. Cool. So I wanted to establish that because then I wanted to move to another thing you've been spending a lot of your time on is the resources necessary to do that. Can you talk a little bit about TensorFlow? Some of the hardware. Where's that going?
Yeah. So TensorFlow is kind of this open source, machine learning software system that we've put together specifically for our own research and deployment of deep learning systems at Google. And we made a decision to develop it with an eye towards open sourcing it, and we decided to open source it in November 2015 so that we could essentially have the entire community around the world work to improve the system rather than making it a proprietary thing only for Google internal uses, of which we have plenty. But by having this tool be something that lots and lots of companies and organizations can leverage, I think the whole community is better for it. And this is just a graph of GitHub stars, which is sort of a weak measure of interest in how excited some community members are about particular projects. And that's TensorFlow's graph since we open sourced it. You can see when we open sourced it, and showing a bunch of other sort of open source machine learning packages. And so we now really have a very vibrant community around this. And there's lots of good examples of how to use TensorFlow in our tutorials set up, of how to use it to do translation or to do sequential prediction things like the customer record example I described. The translation example in that the tutorials is like a pretty good setup for that. Lots of computer vision examples. That's really, I think, been good to see that the community is adopting this and using it in all kinds of ways we wouldn't have expected.
Yeah, that's great. So huge traction there, and on the hardware side, maybe we'll get to that later, but you've been talking about finding a way for other companies that don't have the resources like Google to implement some of these things like TensorFlow at scale. Now, you've open sourced that so they can start using it, but for those without extensive machine learning expertise, could you talk a little bit about what you're doing there and what we should see coming from Google?
Sure. I'm going to skip over the translation results. I can talk about those in a moment if you want. So one of the things about deep learning is that it's pretty computationally intensive. And so that's why, even though a lot of the techniques were developed in the 80s and 90s, they really just couldn't sort of scale to problems of practical size and importance until about 6-7 years ago. And so people are using a lot of computational things like GPU cards to get more sort of floating point performance, which is what these models really care about, is how many multiplies per second can you do. And so we've actually been building our own hardware customized for training deep learning models at Google. And so this is sort of the second generation of those, which we're making available through our cloud as a cloud TPU, a tensor processing unit. And it's also designed to be hooked together into these large, multi-rack systems, which are essentially like ML supercomputers. And that really scales in a lot of interesting ways. One is, can you train very large models on large data sets? But also it makes experimentation cycles very fast. So if you can try something out from a machine learning perspective in an hour instead of a day, that's just a fundamentally kind of different way of being able to do science and try experimental things. And so computation is pretty important. One of the things we're really excited about in our group is we're doing a bunch of research on automating the machine learning process. So the current way you typically solve a machine learning problem is you have some data, you have some computational devices, GPU cards or maybe TPUs, and then you take a human machine learning expert and you kind of stir them all together. They run lots of experiments, and you hopefully out of that you get a solution to the problem you care about. So one of the things we're excited about is, can we turn this into data plus a lot more computation without then needing as much machine learning expertise? Because that's sort of a real limiting factor in how much machine learning can spread around the world. If we think about organizations around the world, there's probably 1 million organizations that should be using machine learning in some way, but there's probably order thousands that have hired machine learning people and are actually deploying it into real production systems. And over time, as more people get trained in these sorts of techniques, that 1,000 will grow to 5,000 or 10,000 in the near future. But it's going to take a long time to go to all million if the way you solve problems requires sort of someone with lots of deep machine learning expertise.
Right. So there's three question marks at the bottom of that slide.
Yeah.
I'm wondering, is that an emphasis from you, Jeff?
It
is.
is.
A tough
We
question.
have early signs that we can do some of this. So let me just highlight this. So one of the big questions when you're using deep learning is, how should you connect together the fundamental building blocks into a model structure that solves your problem? And so what you see here is we've implemented a system that can sort of automatically try lots of different configurations of these things. And it can do it very, very rapidly using lots of computers, which is sort of the kind of thing a human machine learning expert would try. And so what you see on this funny diagram here is a structure that it came up with that performed very well on a problem that's been pretty well studied in the machine learning research community. And it gets sort of almost the state-of-the-art result in this problem without a human machine learning expert being in the loop in designing that structure. And it looks kind of, most human machine learning expert things would look a little more structured. This looks a little more kind of organically designed.
And what time frame do you think something like this will appear, Jeff?
Yeah, I mean, I think
in terms of helping with the machine learning expertise side of that.
Yeah, I think this is the kind of thing, this is obviously a really ambitious goal, but along the way, we're going to have sort of ways to solve particular kinds of subsets of problems, or maybe problems in specific areas that will, be available, not too far from now, I would say. I think, this is not many years away. This is like, months, quarters, that kind of thing.
Yeah, right. So an example of a vertical, would that be, say, health or marketing engagement with customers?
It might be more, instead of a vertical like a business area, it might be more of a vertical like a specific kind of problem that is broadly useful for lots of different kinds of businesses. This is, for example, a computer vision problem.
Okay.
And there's plenty of computer vision problems that people care about, but where they actually want a model for their data. Is this a broken airplane part or a not broken airplane part, and they have visual data that can help indicate that or something like that.
Right.
And
so even with that machine learning expertise, a company is going to need to know how to collect the data and to model to make sure that they have the right problem they're trying to solve, right? So you're not going to come in from soup to nuts and help them. They need some basic framework.
Right. So you need
the problem they're trying to solve, the data, they need that scale.
Yeah.
You're not going to help them get the data. Once they have that, then you can plug it in.
Right.
Okay.
I mean, there's a lot of work in machine learning systems that is not actually machine learning.
Right.
And so you still have to do a lot of that. You have to sort of get the data together. Maybe you have to have humans label examples. And then you kind of have to write some data processing pipeline to eventually produce a data set that you can then do machine learning on.
Yeah.
And we're not yet automating that. But I think the actual machine learning stuff, which is much harder kinds of expertise to come by, that is what this technique really kind of helps enable. And actually, it's not just for small problems. If you look at ImageNet, which is the thing that went from 26% down to 3% error, this is an interesting graph. So all the black dots are examples of sort of prominent computer vision research groups that have spent months or years trying to come up with a solution. And this graph is showing you a plot of the amount of computation in those models to give you a prediction for a single image. So generally, more computation gives you more accurate models, and the accuracy of those models on the y-axis. And so all the black dots are sort of human design things with years of research behind them. And then the red dots are our AutoML solution for the same problem. And the interesting thing is the two green areas, or actually the entire set of red dots, is outside the set of black dots, which is what you care about. So we can produce sort of more accurate solutions with less computation than sort of some of the best computer vision sort of research, sort of human design models in the world. And that's true both at models that are very computationally expensive on the right, and also for models where you might want very cheap computation so you can run it on an Android phone on the left.
So we could talk for a long time. I wish we had more time. I want to pause for questions. Just one last question for me. You've talked about the multi-model approach, where you have a system that can be artificially intelligent across multiple areas, right? So that you can handle at the same time language processing, image recognition, and so on, translation. Yeah. Where do you see that going, and how long is it going to take to get us to that? I mean, people have kind of, there's an equating with general artificial intelligence, but maybe that's a bridge too far. I'm just wondering where we're going and when do you think we're going to get there?
I mean, I think one of the things you see in machine learning today is we typically try to train a model to do one specific thing and to do that very, very well. And because of that, we need a very large amount of data for that particular thing, because we're essentially trying to learn from nothing, right? We start out knowing nothing, and we try to learn everything about the task that we care about from someone giving us 1 million photos. But that's not really very reflective of how people learn to do new tasks, right? We can do 1,000 or 1 million different things, and when someone tells us we need to do a new thing, the 1,000,001st thing, we learn from all the experience we've built up in doing the first 1,000,000 things that we've learned how to do. And we can say, oh yeah, this problem looks kind of like these other 9 that I already know how to do, and I can kind of cobble together a rough idea of how I might solve it. And when I learn as a human a new thing, I don't need very much data for a new example. I don't need many examples to learn how to do something. So I think we need to kind of aspire to that in machine learning research as well.
Great. I did want to open up to questions. Does anyone have a question for Jeff? We got a runner here. There's a question right there. Sorry, I can't see because of the light. Oh.
Hi. So,
okay.
Yeah. It seems the data is foundational to the models that you train, yet a lot of companies are wary about their proprietary data leaving their 4 walls. So for you to bring these capabilities to the hundreds of thousands of those smart companies, how do you address this concern? And once you train those models, who do those models belong to, essentially?
Can you introduce yourself, too?
My name is Mandeep, and I'm a master's student at Stanford.
Okay, sure. Yes, so I mean, I think part of that is the reason we open source TensorFlow. So you can take TensorFlow, download it, and run it on your own computing environment, on your own data. That never has to leave your 4 walls. In our cloud environment, I think for the same reasons that companies are moving to cloud environments where they run on cloud companies' infrastructure, but they control the data, and the cloud companies essentially don't have access to that data because it's kept encrypted by those, by the companies running on the cloud. Same argument applies, except then you get to take advantage of things like cloud TPUs or other kinds of infrastructure like that. So different situations are different. Obviously, if you're training on your own data and you create the model, then you own that model.
Have time for one more question? Yeah. Actually, let's take two questions since there's only two. Yeah.
Hey, Jeff. My name is Sid. I'm a chief scientist at Conversica. My question is more related to where AI is heading to in terms of monopoly. Do you feel like in the coming years, it is possible for startups to play a disruptive role in artificial intelligence, especially, say, natural language processing or conversational AI, or with the rate at which advances are being made by Google and Facebook and Microsoft and Amazon? Do you think these four companies or companies with similar resources would leave a vacuum for startups to explore?
Well, I think the whole AI space is quite vibrant. So there's lots and lots of startup companies doing pretty interesting things in a lot of different ways. There's startup companies doing machine learning hardware. There's startup companies using machine learning to tackle particular kinds of verticals or to build horizontal solutions. And obviously, as you mentioned, big companies are investing heavily because we see opportunities for using machine learning in our own products. I think it's so early that it's really hard to tell what's going to be successful. And really, we don't actually know what fundamental learning algorithms should be used for things that are not supervised tasks, right? Supervised tasks work pretty well where you have inputs and outputs that you care about, and you can train a model on that. But we don't know how to take advantage of unsupervised data in the world where you just have examples of images or videos or speech, but you don't know what is in it. And so I think there's fundamental research to do there, and that research breakthroughs could come from anywhere.
Great. Yeah.
Hey, I'm Nathan, and I lead the data science group at Rally Health, a subsidiary of United Healthcare. I was wondering if you could talk a little bit about use cases where ML is the right choice, but maybe one of the older ML algorithms like linear models or random forest.
Mm-hmm. Yeah, so I think for cases where you don't have very much data, some of those methods tend to work better because they sort of more data efficient, and some of them I think can be more interpretable. So for example, for healthcare applications, sometimes an interpretable model is a really critical aspect. There's a lot of work on deep learning models to make them more interpretable. So I think it's not necessarily going to be an either-or choice in the future. At the moment, it is a bit sort of more opaque in terms of some of these things. But I think if you have large amounts of data, deep learning models are generally showing that they're performing better on more and more tasks over time. But those other kinds of approaches have their place as well.
So the future is deep learning for every ML problem?
Well, I would say at the moment, deep learning is having a lot of success. I don't think it's the only the only tool we'll need to really build much more intelligent things, but it's a pretty key building block that will get us some of the way and can solve interesting problems now.
Jeff, thank you very much for your time.
Thank you.
Yep. Good job.
Appreciate it.
Yeah, thanks. Yep. Up to you.
Fantastic. Thank you so much to Jeff Dean and to Matt. And now it gives me great pleasure to keep this moving on today, talking about how AI is changing the game for an industry giant. Please welcome to the stage, interviewed by Rich Wong, General Partner at Accel. It's Jeremy King, the CTO at Walmart. Please give him a warm, warm welcome.
Okay, good afternoon. It's good to see everybody here. It's my pleasure to have a chance to interview Jeremy, who is also a Bay Area native like I am. I'm originally from Sonoma County. I think Jeremy's from Morgan Hill originally. Yeah. There's not a lot of us true original locals here, so it's great to see us working in the local industry here. Well, Walmart, it's hard to know anybody who doesn't know Walmart, but some statistics maybe to tee it up, and I'm sure Jeremy will expound on it some more. Founded in 1962, 2.3 million associates or employees in the company, obviously out there on a global stage, about what, 12,000 stores, I believe, around the world, 60% of the US, I believe.
Right.
And Jeremy has been with Walmart for 6 years as CTO and EVP. And before that comes from the startup world that I come from with LiveOps and eBay in the years before that. So has a great blend of experience in startups and traditional Valley companies and now leading the technology for it at Walmart. Great to have you here, Jeremy.
Right, thank you. Yeah, Excel and Walmart have a long history. Like back in Walmart.com days, 1999, 2000, right? They kicked off the .com part of Walmart back then.
That's right. That's right.
Yeah.
That's a reason why Walmart has operations out here on the West Coast, as well as previously we were investors in Jet, which is now part of the Walmart family.
And Bonobos. I'm wearing my Bonobos sweater.
And Bonobos,
today, right?
exactly. Well, why don't we just start off with, Jeremy, why don't you talk a little bit about the scope of your role? I mean, you have a very broad swath of responsibility. Just talk about the areas of coverage, and then we can dive into the practical applications.
Yeah, it's a great question. I started at Walmart.com building their e-commerce platform. They had, after the 1999 acquisition, they had sort of left it, like most retailers were sort of still deciding what they were going to do with e-commerce, and it sort of left it alone by itself for many years. And so I came in really to come in and rebuild the Walmart.com platform and really looking at Sam's Club, Walmart Mexico, Walmart Canada, that sort of thing as well. And then after about 4 years of that, we built a completely new architecture, all on open source tech, and rebuilt the team completely from the ground up. Really building I used to call it the startup inside the world's largest company, and it's really hundreds of little startups inside the world's largest company. And the success of that, about a year ago, a little more than a year ago, Doug, the CEO, and I started talking about sort of the next generation as how do you integrate the digital and physical part of the organization even tighter. Mm-hmm. And so we made an organizational change back in February that really split the role of the CIO and the CTO. The CIO really focusing on the internal parts of the business, SAP, the business aspects in HR, brought in an excellent leader, Clay Johnson, to run that, who's just terrific in that space, and then really put the stores technology and the e-commerce tech all in one organization, which is what I run.
So you take waves of technology, whether it's say mobile technology over the past 10 years and now machine learning and AI. How do you decide where to start with from an innovation perspective? I mean, you have a gigantic set of physical stores, which is the heritage of Walmart. You have the rising importance of e-commerce. Obviously, mobile commerce is a key part of that. When you have that how do you decide where to focus and where have the ML and AI efforts started from? Yeah,
it's a great point, because what is really happening, and like I said, as we built the organization, we really wanted a large organization to be effective is to really set it up with a bunch of mini organizations. So when you think about some of our first efforts on personalization, the search engine, the supply chain, all the catalog work, we went from 700,000 items on the website to well over 60 million now. And when you scale those things, what you have as a problem you have to deal with. And so the teams would sort of individually focus and start building the platforms. And some of the early successes we saw, even against sort of incumbent competitors that are in that business, we'd put 2 or 3 engineers and a machine learning specialist on it, and we were able to beat the sort of third-party app pretty handily. Right. And so those sort of came out organically initially. And what the great part about having the combined efforts of both the e-commerce team and the stores technology team is you get sort of this drastic amount of scale. We talked about the scale that Walmart has. We have unbelievable scale across all of our different business units. But taking
hit some of those stats, because I don't think everyone is up to date about that.
It's pretty amazing. I mean, you talked about the number of stores. I mean, over 10,000 stores and 2.6 million associates. But we have when you look at the number of we were talking about the amount of miles that the trucks drive around the U.S. It's like here to Jupiter and back, right? That sort of scale is amazing. We're going to sell like 150 million pounds of turkeys and pork at Thanksgiving this year. So people, when they talk about the amount of scales, I think it's like something crazy, like 2 million ugly sweaters are going to come out of Walmart, right? And these kind of scales, you can really see. We were talking about places where machine learning can really help. This is really where scale helps machine learning in a lot of ways.
You have the density of data to actually pull it off.
Yes,
right?
exactly.
So you mentioned a stat a moment ago of going from, was it 600,000 SKUs to 60 million, or I'm not sure I quoted.
Yeah,
right.
it was when I first started. It was about 700,000 items on the website, and like I said, we're way over 60 million. And when you're dealing with that kind of data, I mean, you're talking about, that's just the items on the site. Think about the amount of inventory changes and price changes and just, adding new pictures and deciding, what category things are in. And I was talking about machine learning problems before we came over. How do you determine that, an automated feed that coming from a third-party vendor, whether that price is right or not? Right. And you can get into real problems where an item's selling really well, and then the next day it's not selling anymore. What's going on? The price got accidentally jacked up, 40% because of a clerical error. And how do you identify those things at scale, right? And that's some of the great parts about working at scale and building tools. We have unbelievably solid merchants in our organization, but dealing with those types of things at scale become a problem. Like, how are they going to notice those problems? So how do I make the man versus machine combination really work well together?
Right.
That's what we're after.
So we've established this incredible level of scale that Walmart has, both online as well as in the physical stores world. Well, let's dive into the question of how is ML and AI being applied, and what is a realistic blend of hype versus where do you actually see practical progress being made? So start with that broad question, and we can dive into a couple of the use cases.
Yeah, absolutely.
Verticals.
Well, as I mentioned, I think inside our company, again, both organically in the stores and on the e-commerce side, we focused on things that you would expect. Search, the search algorithm and making search better. The website, as it goes to personalization, there's lots of rich data on personalization. We launched a feature that talks about easy reorder and not only looking at your past purchase history, but also dealing with, I was talking to one of our companies, Johnson & Johnson is about to redo their entire line of products, and they're going to change every UPC that they have in the website. And you can imagine when you're shopping on Walmart.com, one of the things you're looking for is reviews and feedback on. And as companies make these types of switches, how do you make sure that people understand that these are not necessarily the same product, but they're very relevant for each other? So recommendations, reviews, and that sort of thing. Supply chain, unbelievably solid progress on supply chain, where you can, I mentioned not only the trucks, but things like replenishment, and how do I know, there's some great statistics on how do I know how to optimize items that aren't the highest sellers, right? High sellers are pretty easy to predict, but when you get into sort of low sellers or seasonal items, we were just talking about how do I predict seasonal items regionally, right? So we might be, ugly sweaters might be super hot in Hayward or whatever up north, but super low in Morgan Hill, right? So how do you predict those types of behaviors when you're talking about a micro level? It's really interesting.
I didn't mention this, but one of my first projects out of business school was a Puffs brand manager. So I came up with the idea for holiday cubes to be sold into Walmart and other places, and we massively mispredicted how much volume these holiday cubes would have. So they ended up in some secondary market, some dollar store. This is my career ended at Procter & Gamble. I ended up
your career ended
the West Coast to work in consulting.
Exactly.
So let's talk for a second about some of the examples you described. Can you share some of the metrics, or what were the actual hard results that came from some of these different initiatives?
Yeah, I actually brought some stats just to make sure. Like, on search, for example, one of the things that becomes really interesting when you look at a catalog that big, everything is better with classification, as my brother used to say all the time, which is you have this huge catalog, and you need to make sure that things are classified in the right place. They're able to detect problems. We were talking about how many days would it take a human to actually go through our catalog and make sure they're classified. It was like 8,500 days. It's essentially impossible to do. You could throw bodies at it forever and never get to the problem. So those types of things. And I was talking to our head of catalog, and we were talking about how much better our catalog can be. How do you classify an item that we were talking about home products, which we sell a ton on Walmart.com. How do you classify an item as modern or chic or a country or whatever? Right. Those types of things are not things that you often get really from the manufacturer. Right. You have to sort of figure out how to classify those things based on other like products, and you can use data from other sources and figure those things out. So that's one big piece. The other big piece is talking about things like A/B testing. A/B testing is awesome, and many people have got a really mature A/B testing framework. But as most machine learning problems, the problem is data, right? How fast can you get results? Yes or a no. And we've taken, using our machine learning programs, we've taken typically what would take a few weeks of data collection down to just a few days. So we're like a 90+% drop in just figuring out whether something is a success, yes or no. And those types of things are big. On forecasting, we were talking about forecast accuracy. I talked about we reduce losses, where our prediction is we're going to reduce losses by 35 million on low volume items, right? And it's really, how do you predict better on low volume items?
So that just means you're sort of stocking them more centrally, so you're not having to have them stuck out in a regional
or
store or DC? Or
yeah, exactly. Figuring out how much to put in each area, or even in this case, it was e-commerce. How do you determine how much to buy and how much you should replenish? Those sorts of things based on seasonality. And we think just on e-commerce, 35 million is a lot for low volume items and that sort of thing. Right. And then we're doing a lot of work with robotics. I talked a little bit about that before, but there's quite a bit of work that can be done both in the warehouse and in the store on robotics as well.
Right. So a topic that comes up when this is covered in the press, of course, is how much does automation, AI, robotics, to what degree does that affect the employee base and the associate base? And obviously you're one of the, Walmart I think is the largest employer, private employer in the United States. So how do you both talk about that internally, as well as what is your broader view of how robotics affects the nature of work and the nature of jobs in this country and other countries?
Yeah, I think that's a great point, Rich. Not only are we the largest employer, only the U.S. government and the Chinese government, I think, are the only bigger employers than we are. But we do also,
and only the Chinese Army, I believe. Actually.
Yeah, exactly, Chinese Army. We have, we're also a company that really is purpose-driven. We save people money to live better, right? And these values have been part of our company for a long time. We hire, 170,000 veterans, for example. We're the biggest employer of veterans as they come back. We have just a massive amount of donations to the hurricane relief funds. Often people talk about, Walmart being first on the scene before FEMA gets there and that sort of thing. That's still true. And we had obviously a disastrous last couple months. But watching it, really running the operations center for getting the trucks back online, getting power back to the buildings, that sort of thing. We spend a lot of time with the humans, but also how do you get the machines back working? And Walmart wants to lead in this area where we're gonna have a combination of man versus machine, and we have done a lot of research and talked to some futurists about it. And what we really feel is, people talk about job displacement a ton. What we really feel, it's really more like job augmentation. And most jobs will be augmented by machine learning. And to some extent, I talk about it, you get to do the more fun parts of your job.
Give an example.
There's a couple of examples. I think we were talking about the pricing examples. How does a merchant really understand pricing variances and that sort of thing? If one of our competitors is selling a product that's much cheaper than our costs, then you can pick up the phone and talk to the vendor. What's going on here? That sort of thing. It's hard to have a human figure that out on their own at scale. The other big one is the robotics piece I mentioned. We're doing some work right now with a robot that effectively goes down the aisles and scans essentially what we call for outs. It's really looking at the aisle and not only using machine learning, but just image recognition technology to understand if there's something that's out of stock, or oftentimes it's in the wrong location. This is one of those jobs. I worked at a drugstore right as I was in high school in Morgan Hill. And this was one of the worst jobs ever, right? Going down the aisle and seeing which items are in the wrong place and that sort of thing. But the robot can do that really well, and will increase our on-shelf availability and really make sure that we're keeping our inventory in great spot. And it can go down these aisles in about a third of the time that it used to take a human to do it. And as a result, it can go many times per day, if you know what I mean. And it's a huge change in our productivity.
We will take some questions from the audience. I have one more question, and then if you would raise your hand, we'll then get it queued up, so when I'm done with this, the microphone will be wherever it is. So please just raise your hand if you have questions. So one question around ML and AI I just wanted to ask before we get to whoever's next here is whether or not it's sort of a major centralized effort, or it's 1,000 small experiments that you have inside individual business units and product teams, and how you navigate that effort as CTO. So maybe spend a second on what do you run in a centralized form, and what do you run in terms of small tiger teams that are out there just trying and experimenting with different tests along the way?
We talk about this all the time, and actually have a lot of interesting thoughts about it, but also we'll love some audience or post feedback. The pieces that we can centralize, one of the big pieces that we talked about earlier is how do you gather and collect the data that you need in order to feed AI or machine learning. And we've centralized that piece because many companies run through this problem where you have two reports, both have a number on it that says sales yesterday, and they don't match because they came from different systems. So we had to make sure that the foundation of most things in retail are effectively, hey, is it sales or inventory or stock? How do I make sure those foundations are not only correct and matched, but also fed relatively frequently. We have feeds on all those. And the second piece is really the underlying core platform, the cloud architecture that we have. So I don't want my engineers worrying about whether I can get GPUs next week. So how do we centralize that piece so people aren't out running around trying to get compute? But right now, the rest is really decentralized, and we have a bunch of work going on with TensorFlow. We have a bunch of old, sort of traditional machine learning models that are being worked by each org. But it is really hard to find a particular platform that can handle supply chain as well as the search engine, as well as personalization and merchandising. It's unclear to me that there'll be a single core platform that can handle all of these pieces. We do a ton of work. Almost all the new experiments I've seen are all based on TensorFlow. So maybe that's part of it, but we'll see how it goes going forward.
Thank you, Jeremy.
Yeah.
Let's see. There are questions in the audience. I don't know where the mic.
So down here in the front row on your right.
Yes.
Hi, my name is Kevin Spires. I'm Director of Strategy and Innovation for Coke Industries. You may know us we own Georgia Pacific, so we have a lot of our product is in your stores.
We sell a few.
Yeah, a little bit. So one of the things I was interested in is how are you going to partner with folks like us, perhaps in this robotics where you're checking aisles. One of the big challenges that we have is we're fighting for inches of counter, right? So in shelf space. So how do you foresee us partnering in the future on projects like this to make things even more efficient? Because I think we have a lot of the same problems because we're warehousing from our locations to your locations into the store, and then have to take care of the store along with
Okay, let's let him answer.
Yeah, let me answer that. So, Walmart has a huge history of sharing our data. And as a matter of fact, we've been an open data company forever. Retail Link was invented and frankly, oftentimes is cited as one of the secrets of success of Walmart is sharing our sales data back with our partners and figuring that out. The question is how do I just continue to add to Retail Link so that you're getting that data? And again, I think the thing that's most interesting to me where machine learning can help is how do I determine micro, I was calling it sort of each store being its own independent story. Oftentimes we look at things in sort of groups of 200, but there's no reason that I can't look at a store one by one using this technique, right? Where we would share sort of regional or very specific areas. We can do it much better at the store level, and I think make both of our companies even better.
Thank you. Why don't we squeeze one more in, this gentleman?
Yes, sir.
Thanks so much. John Kutsier, mobile economist with Tune. You have about 2 million products now available with Google Home. Can you talk a little bit about assistance, voice, and ordering, how that factors into the future for you?
Yeah, absolutely. So we launched our 1,000th store, our 1,000th pickup location in Seattle, by the way. But that's another story. But we can we effectively are using Google Home essentially as our voice assistant and are partnering with lots of other voice providers to help make sure that when you say, hey, I need toothpaste, how does it know which toothpaste that you want? And back to the point, I know the data you have, I know your previous history. So basically we link the Google account with the Walmart account so that it makes your shopping experience completely seamless. And that's the plan, working with Google and others to make sure that we use our data in an open way that you select in, you opt in on to make the shopping experience completely seamless.
Please join me in saying thank you to Jeremy for
thank you guys.
Excellent
See
discussion.
you here. Appreciate it.
Fantastic, thank you. That was awesome, thank you so much. We're going to keep this moving right along for everybody here and everybody watching online. Talking about AI will drop your customer support by 90%. It gives me great pleasure to introduce on stage Julie Ask, VP of Forrester Research, who'll be doing the interview with Greg Spratto, VP of Operations at Autodesk, and Rob High, IBM Fellow, VP and CTO of IBM Watson. Please give them all a very warm welcome.
Freedom, freedom, I can't move. Freedom, cut me loose. Yeah. Freedom, freedom, where are you? 'Cause I need freedom too. I break chains up on myself.
All right, 20 minutes. We're going to go fast. So Greg, let's start out. Tell us, I don't know if everybody in the audience knows what VP of Operations is, but tell us just, like, quickly, what's your role at Autodesk?
Yeah, so my role at Autodesk, amongst other things, primarily is to handle our customer support operations, which is about 1 million different calls that we get in a year, from everything from our customers to our channel partners, anybody who might be having an issue with one of our products, just an issue using our software. So we have a team of people around the world who is responsible for handling those customer service issues.
Okay, and Rob, CTO.
CTO, I'm
the big
responsible.
brain behind all of it, the Watson, or are you? What's your role?
You know, we work in worlds where these things only happen because of all the people that come together. My role is actually is responsible for driving the technical strategy, for creating a vision and driving the teams to rally around trying to accomplish what we want from this technology.
All right, thank you. So Greg, let's tee things up here just before we get into AI. Talk a little bit about the challenge that Autodesk was facing that led us, you know, to the point of using Watson and getting outside on stage here.
Yeah, like many companies, you know, we're no different, where the demand for immediacy of a customer service interaction just continually increases. And so, you know, we no longer could scale our operation merely by adding more people. We had a pretty poor resolution time, certainly not what we would want to have with our customers. Inconsistency of answers, you know, depending on what agent you might get to. And this is through all the best intention of trying to do it right. We just couldn't scale to a level that we thought was appropriate for the customers that we're servicing. And so we figured we had to look at the problem differently than we had historically.
And so how did you get to, and we can talk in a moment too about like what AI, because I know it's a kind of a big umbrella of a lot of technologies fall into that, but how did you come to the conclusion, you know, I know you said you couldn't scale this anymore by just adding more bodies. How did you come to the conclusion that some element or some form of artificial intelligence was part of your solution?
Well, we were lucky enough to have a chief strategist who was on the forefront of looking at different ways for us to solve our problems. And he had begun researching alternatives beyond just human capacity, began working with the folks on the Watson team. And really it was a matter of matching a need that we had with some available kind of smart people on the IBM side. And we kind of co-developed, you know, a solution that was right for us. I wouldn't say we walked into this expecting to land up with a cognitive solution.
Okay.
It was one of those things where I think we had our own burning platform, and they happened to be there to help rescue us. And it turned out that we kind of struck lightning in a bottle and came up with a solution that was, the demand for it has just been exceptional. And the customers continue to want to use Ava, our intelligent assistant, to handle some of the simple transactions they have with us.
So I want to come back to a few things that you just said, but Rob, just for the audience, can you help level set a little bit? Is what Greg's describing something you hear like 6 times a day when you're walking into a new organization, or is this something that's kind of new?
The most common application of AI is in these conversational agent scenarios where either for customer support, customer sales, customer interaction, customer engagement, you want to augment the kinds of interactions that you have with human beings. In fact, really when we think about AI, I tend to prefer the term augmented intelligence because I think it brings more clarity to where our emphasis is. And whether that's around a conversation that you're having with a human, whether that is in extending their own knowledge and reach so that they can now perform the tasks and their jobs better, those are all examples of where we're seeing AI being applied.
So since we're talking about the human element, there's a few layers, Greg, that I want to pull back. But let's start with just Ava. So you named your agent.
We did, yeah.
Like why is that significant that you decided, and it's a woman, or a her, so to speak.
It is.
Go ahead.
Yeah. It's been the thing I've talked most about probably is why human, why a woman, why Ava. So a couple of things. First and foremost, I don't think that there's anybody who wakes up in the morning who has a desire to talk to customer service.
Okay.
And I think we've all been trained that folks who run contact centers will do everything in their power to prevent you from talking to a person.
It costs money.
It's
expensive.
It is, and through all the best of intentions, we tend to make it hard. So we start customer engagements with a lack of trust from the customer to us.
Okay.
What am I going to do when somebody calls to make it hard for them to get their answer resolved? I didn't think if we put something that was a symbol or a goofy image in front of people and said, this is a better way than a human to get an answer for your simple transactions, I don't think they would have trusted us. I think we needed to put something there that was sophisticated, that showed that we valued the importance of their question, and that was serious about being able to solve it for them. So that was the primary reason. Now, why Ava, why female? We're going to go to voice. When you go to voice, you have to pick a male or a female.
Okay.
We weren't going to do some silly robot voice, and so we kind of defaulted into it because Autodesk Virtual Agent, if you put it into an acronym, spells Ava.
Okay.
Now, one last thing. We also wanted Ava to represent our human workforce. The vast majority of my customer service agents are female. A lot of studies about female agents being more empathetic, being better listeners, quicker to resolve, more trust between customers and female agents. So we took all that together in blending and making Ava.
Is that the
I'm
gender
sort of
listed on
fascinated
her
by the
birth
psychology of that.
Yeah.
I'm sorry, Rob, what did you
Is
say?
that the gender listed on her birth certificate?
It's funny you say that. We basically have to treat Ava almost like an employee. Yeah. I mean, she has her signing credentials.
Is it like Flow and Progressive? Does she have? Is there like an embodiment? Do you know what hair color she has?
Down to how much Botox is in her cheeks and lips, and that is not a joke. We're working with a company on something called embodied cognition, and every stitch of what Ava looks like, including her purple eyes, was a creation of myself or somebody on the team.
Okay. So let's take a step back to when you were starting the implementation, because saying, hey, we can't scale with humans, we need AI.
Yeah.
We have like a functioning call center where we're rerouting calls, to Ava rather than my agents. Yep. There's a lot that has to happen in between. So talk us through a little bit about how you got started and why you got started, because I think, one of the questions that I would have if I were in the audience is, Jeff was up talking about like scale, you need large data sets. Do I use my own data set? Do I need a third-party data set? Do I have enough data to use neural networks? Right? There's a lot that has to be unraveled. Right. And at some point, you have to start somewhere.
Yeah.
So talk to us a little bit about where you started and why and how you evolved from there.
Yeah, we started our simple and biggest use case, which was around the issuance of activation codes. And that was between 25 and 30,000 requests a month for a simple serial number. And we had years upon years of data, whether it be from caseload that came in, chats, voice calls, all of that was data that we could use now.
So let me ask you, so on one hand, you had a lot of data.
Yep.
And the second thing, not to oversimplify, it sounds like they were asking a pretty simple question.
Very simple question.
Okay.
Now, it turned out that it was a lot more complex than we had thought. I kind of describe it as we thought we were dealing with something called candy, and then we learned it was something maybe called Skittles, then we learned it was something that was green, yellow, red, orange. It got a lot more nuanced as we got into it.
So give the audience an example. Like what's a real world example, or an example from Autodesk?
Real world example would be, I just got a new machine, I just reinstalled AutoCAD, need a new activation code.
Okay.
And we get hundreds of those every single day. And previously, that would be handled by an agent.
Okay.
Response time on something like that would be measured in hours or days. On
Hours or
something,
days?
Hours or days.
To start using the product, okay.
38 hours on average to
Okay.
resolve that type of question. And that's just not satisfactory. You know, that's downtime for our customers. So we started in that use case, and then once we proved it to be successful, then we said, okay, well, let's expand it to some of our other kind of tier 1 simple customer service sorts of questions, the types of things that would typically be outsourced, were things that we looked at saying, well, we think Ava can handle those as well. And then we moved on to 40 more use cases beyond just that activation code.
So you went from 1 to 40
Yep.
to...
And we just continue to increase them along the way. So I don't think we have a set idea in mind what it will expand to.
Okay.
The team continues to grow a little bit as we move along the way. We have 5 conversational engineers, which are all about, getting the dialogue right, managing our intent and entity structure, making sure that Ava truly is a conversational agent and not a chatbot. By the way, chatbot's a 4-letter word. We shouldn't be using that when we're talking about cognitive powered assistants. They are conversational agents. And the team continues to grow, and as our knowledge grows, we continue to expand what she does. It's all about skill development of Ava.
Okay,
and if
so
I can put a little context on this, so I mean, there's often, we typically talk about the long tail, where if you think about sort of the distribution of kinds of questions or problems people present, it's very common that in most institutions there'll be a certain number of questions that lots and lots of customers, consumers will ask. And then as you move down that long tail, you find fewer and fewer occurrences of the same question, but the variety of questions that people ask continues to expand. So it's, in most cases, almost unbounded how much you want to cover, how much spectrum you want to cover, but by focusing first on what we call the fat head, the beginning of that long tail, then you're getting the greatest bang for your buck, if you will, for the investment you're going to put into trying to address that set of issues. But if you really want to engage people, you've got to be able to deal with the variety of problems they're going to present to you.
So I want to come back to that too. That's a really good point that Rob's making. I want to come back though, Greg, first to something that you said, because there's this human element that's part of this. So on one hand, and I want to go down 2 paths here, so I'm going to ask you 2 questions, but we can come back to the second one. The first is, if this is kind of your traditional machine learning, then somebody's got to train Ava, like it's right, it's wrong, that was pretty good, unless we're using deep learning here. So and certainly there's this fear, well, first of all, who's going to train Ava? And then there's always this fear, I think, from your staff, if we read all the press, that their jobs are going to go away.
Right.
So how do you start the process of, on one hand, getting their help to do the training, but on the other hand, alleviating the fear of, obviating the need for my job if I train a machine to do my job for me?
Yeah, so I mean, we do have very sophisticated data scientists who are helping on the project, but by and large, these are people who know the customer service area exceptionally well, and they can tell the difference between all these nuances and what gets asked. And so we need a whole variety of subject matter experts, and quite a few new jobs have been created
to train Ava.
To help train Ava.
Okay.
To help us understand what we're looking at when we're looking at 2 different cases that may seem similar but are completely different. And we're very open, and we have been for years, by the way, way back to when we started looking at outsourcing. If you're in a highly repetitive, low-value job, we don't want those jobs. Okay. We want every one of our human agents doing more sophisticated, high-value tasks, being able to spend time with a customer as opposed to issuing a simple activation code.
So it sounds like you're replacing maybe to whom you've been outsourcing with technology in-house.
Yeah, that's one way. And then also internally, we have a very nice agent assist model. And about half of what Ava does is just find out what the customer is looking for and then passing it along to a human agent to resolve it.
And if I remember, you said that was about 50-50. Ava's handling about 50% of the requests she gets and passing about 50%
Passing about 50% over. And about, historically, roughly half the time an agent would spend on a call with a customer would be just finding out what they needed.
Right.
And so if we can replace that with a machine, find that out in a matter of seconds or minutes, pass it along to a person, they get immediately to resolution as opposed to being an investigator trying to figure out what's going on, getting them out of troubleshooting and into solving.
So really win-win. So let me go to another stream, and this is something that Rob, both you and the both of you had mentioned. I had never heard of the term conversational engineer.
Yeah.
So I think one of the things that you're alluding to is not only are this job is not going away, but we're actually having to hire more staff and we're looking for new expertise. So tell us a little bit about the new expertise that you need to make this work, and then maybe just quickly, like where do you go find this talent? I haven't heard of that major in like an engineering program yet, if that's even where it belongs.
You want to speak to conversational engineers?
I think conversational engineers, the thing to understand about all this is that at the end of the day, what you're trying to do is engage people. You're trying to bring them into a conversation where not only can you understand and respond to their need, but perhaps even help them work beyond their surface level need to the things underneath that. And if you think about it purely in human terms, a conversation between two people is much more nuanced and involved than just simply, give me your question, I'm going to answer it. That, in fact, is the distinction I try to make between a chatbot and a conversational agent. Chatbots, we've got lots and lots of examples of chatbots out there in the market today, but typically if you look at them very closely, what you see is they just have this sort of single turn nature to them. You know, ask me a question, classify the intent, map that onto some task. What we need are systems that are going to get underneath the covers, and for that you have to have somebody who's willing to think about the social implications, the psychological implications, the emotional implications of what it means to actually engage somebody in something more than just a single turn. And that's what these conversational engineers are really doing.
Yeah.
Go ahead.
Yeah, and in our world, I mean, they are looking at where conversations went poorly and trying to figure out how to change dialogue to make them not go poorly in the future. When we're doing new dialogue, we're trying to figure out the best way to ask things and to respond to things so that we can come up with a successful conclusion to the conversation. And it just continues to expand. And to your question of where we found them, we have hit the absolute jackpot with interns. And we have been extraordinarily...
Like by interns, you mean like 22-year-olds?
Anybody who is in school in the computer science area, we have had phenomenal interns who we've been lucky enough to then hire when they have graduated. These are exceptionally bright people.
Do they cost the same as a regular computer science? Or
well,
do
some
you
of
have
them
to pay
might be
a premium?
watching, so sure, they cost the same as a regular data scientist. No, I mean, clearly, they're out of school, so they are probably on the lower end of a pay scale of what some are making, but you know, this is not a space that's been around for 20 years. You know, this is not something that you're going to get an extraordinarily different amount of expertise from somebody who has maybe been doing it for a few years versus 5 or 10 for what we're trying to do. So they have been outstanding, and it's been a great pipeline of us, especially in the Bay Area, where we have some of the best and brightest schools around here. We've been really lucky hiring interns and then converting to permanent employees.
Okay, so I want to follow up on something that Rob just mentioned that we were talking about a little bit earlier today before we kind of close out with talking about some of the benefits. But one of the big nuts that everybody's really struggling to kind of crack here is this notion of intent, right? There's, I don't know, there's like 100 different ways I could say I want to order a pizza, right? And let alone something more complicated like using a design program on a computer. Right. So talk, both of you, just a little bit about how do you begin to build that understanding intent. I mean, that's what's, to me, that seems really hard here, not what words are coming out of my mouth, but to Rob's point, based on my emotion and my context, what is it that I mean and what is it that I really want?
So we're very lucky because the types of things we get asked have not changed for the past 5, 10, 15 years.
So you have a lot of data.
We have a ton of it. So it really was just about pulling enough to create a training set, training, holding enough back to verify what we have trained. And then it is a process of, you're continually improving on what you have. I mean, something new will get asked occasionally and you have to go back in and retrain in some way. But for us, it was not a hard problem to solve because we were in that fat kind of side of it. We weren't into the long tail of things. And it was just about doing the work for us.
Yeah, and for folks in the audience too, one of the things that Greg revealed to me earlier is you have no technical background.
I have
you're
not.
Like
I'm
a poli-sci
journalism major. I'm qualified
and you're running this whole program at Autodesk.
Yeah.
All right.
I hire well.
You hire well.
Yeah, exactly.
Okay. So Rob, talk to us a little bit about that notion of intent before we wrap up here with benefits.
Yeah, this is very common. I think that for almost all of the clients that we've been working with, they have some kind of history of call center interactions. People who have called in, asking questions, trying to solve for problems, and virtually every call center out there today records a lot of those conversations. So you have this enormous body of data to go draw from, and simply pulling back those records, maybe doing transcription on them, but one way or the other, getting those examples and starting there is always a great place to start.
Okay, but would you agree this is one of the hardest things to do, right? Unless I'm asking like a simple query.
So if it gets harder, of course, then that's where some of this conversational engineering starts to become really interesting, because part of what you're trying to do is determine how much can the system answer of that question easily, quickly, well, and then at what point in the conversation is it appropriate to hand it off then to a human agent for them to continue that, which gets back to Greg's point about, now what that really does for the human agents is give them something more challenging and interesting to work with.
Right, and then I assume, you can grow your business without necessarily growing like the head count in a call center.
Yeah.
So, Greg, like in about 30 to 40 seconds, your benefits that you've realized from implementing this just kind of blew me away. Can you run the audience through some of the stats you've got?
So very simply, 38 hours was the human resolution time before we started. For those simple transactions, Ava does them in an average of 5.4 minutes. Our cost per case could range from $15 to $200 depending on complexity of case. I think it'll land somewhere around $1 per case for Ava interactions. And then on the people side of things, again, everybody is concerned that AI is going to take jobs. We are in the business of helping more customers now. So our human traffic in terms of caseload has gone up by about 20% this year, even though all of our SLA metrics have reduced. So our people are able to handle more things and spend more time with customers than they could have previously.
Thank you. So we're out of time, but I believe Greg and Rob, you're going to stick around for the break. Is that right?
Yes.
All right, thanks, guys.
Okay.
Thank you very much.
Great.
Thanks,
Great.
Rob.
Nice job. Thank you. Appreciate it. Thanks.
Thank you. That was fantastic. Thank you so much. We are now going to let you all take a little break. You're going to be able to stretch your legs, get some fluids, make sure that you're ready for the rest of the sessions that we have for you. We would like you to be back here promptly at 4:25. So please go and get yourselves a drink and then come back in here to continue. Thank you so much.
Ladies and gentlemen, our program is about to begin. As a courtesy to our presenters, please silence all mobile devices. Thank you. Ladies and gentlemen, our program will begin shortly. Please take your seats and silence your devices. Ladies and gentlemen, please welcome back Stuart Rogers.
Hello, hello, hello. Thank you everybody for coming back, and hopefully you are now fueled up for the rest of the afternoon, certainly watered and rested. Maybe you've got some caffeine in you. Don't get the shakes, please don't do that. We are now going to continue on, and joining me on stage, I have the absolute pleasure of welcoming Raj Mukherjee. And Raj is the SVP of... That was awesome. Thank you so much for that. Raj is the SVP of Product for Indeed. Please give him a warm welcome.
Thank you.
Raj.
Thanks.
You know, sometimes those things happen with AV teams.
They do.
I was checking the sound system earlier, and it said it had a little sticker on the side. It said, last serviced by Thomas Edison. So probably...
What can we say?
Exactly.
Even in the world of AI, things are still old.
Hey, Raj, you know, Indeed is doing some really interesting things. I mean, you have a site that is a job site. It's HR. It is 200 million visitors a month, yes. Unique visitors a month. Yes. You have something like 90 million resumes, or CVs as we call them in
That's
in
right,
the
in
UK.
UK, yes.
You know, this is pretty impressive stuff, but you've been using artificial intelligence to really fuel growth there. I mean, can you tell us a little bit more about your start point for the first time, and just sort of give us a view of where you started, and then we'll get into the AI and start talking about how you've moved that forwards.
Yeah, look, I mean, I think basically the way to think about Indeed, very simply, is we have been in this industry with one core focus. How do we help people get hired? When the entire company has been all about how do we help job seekers. I'll start with a simple story. This happened this morning. It's completely impromptu that happened. I had gone to see my eye doctor in San Francisco. I walk in, and I literally see this guy, Diego. He walks up to me, and he says, hey, you know, I'm your medical assistant, blah, blah, blah. We'll check your eye pressure and all that stuff. And the next thing he says is, so where do you work? So I mentioned Indeed. And then he just literally, and then he's looking at my charts, and then he gives me a hug. Now, if you're in a doctor's office and somebody gives you a hug, that's not necessarily a good thing. So I just took a step back, I was taken aback, and he said, hey, you know, I have really good things to say about what you do and what your company does. I have found my last 2 jobs through Indeed. And literally, that's exactly what we have been doing for the last 13 years. The core focus of the company is how do we help more people get hired through Indeed than anywhere else. And from our perspective, we have been decently successful at it with 200 million unique visitors that we just talked about. But more importantly, we have, from an ROI perspective, 2/3 of the hires that happen in the industry through external hires happen through Indeed. And it's probably a little bit different when you are in Silicon Valley, you're looking at it and you're like, really? But I haven't not used Indeed as much. How did you get there? Most of the country outside, and in 60 countries outside in the world, we're using Indeed exclusively for finding jobs, especially if you are in certain segments. So from our perspective, now going back to your question on AI and how has all of this happened, it started with AI in very simple terms. The AI when it was not necessarily using deep learning. And now that we are in the world of deep learning, it has evolved and continues to evolve in many, many ways. I'll give you one simple example. In the last year itself, we have literally had more progress in our ranking and relevance than we had in the last 12 years.
Really?
Really.
And that's through the application of artificial intelligence and machine learning?
That's right.
So when you're using artificial intelligence, you know, where is that touching the Indeed system? How is it affecting it from the point of view of the people that are posting those jobs, the people that are looking for those jobs? Where are you applying this, and how is that working for you?
Pretty much everywhere. And I think there were a bunch of speakers before me who were talking about use of AI in different systems. Look, I mean, Indeed at the core is a search engine. So we are obviously using AI for ranking and relevance. We're using AI for personalization. So if you come in, the job alerts, the emails that you get that says, hey, here's the jobs that are best fit for you as a job seeker, those are all driven by AI. When you think about, we talked about resumes. let's talk about resumes as unstructured data. Everybody's resume is looking different, right? So when you think about what a resume looks like, it's funny, in fact, when I did a search, I think last night or the night before, there are lots of resumes that said I'm a software wizard. Now, when you think about what that ultimately translates to, none of us in this room can directly translate software wizard to a particular job level in any company. What does it mean? So how do you translate that to something that meaningfully can lead to some recruiter being able to understand what this person is doing? That's AI for you. Natural language processing that we are using many facets of techniques that we're using AI for. Fundamentally, if you think about the job search aspect, it's this what, where box. But let me give you a simple example of where we have used data and AI. And this will sound like a very simple example, but it actually is used to show where we are starting to see some benefits. So by default, when you search for a job, you have a 25-mile radius. This is looking for jobs in New York. Normally, you would find a landmass when you're searching for jobs. And 25-mile radius is kind of OK, because you can drive around in the 25-mile radius. Unfortunately, with New York, there's a big ocean in the middle. So you really can't search, and you really can't go and look for jobs in the middle of the ocean. So what you tend to happen in this case, when we started looking at the search data, we found that people were looking for jobs in the Manhattan area. All the blue dots here represent jobs that they were searching for and clicking on. All the red dots represent jobs that nobody was clicking on. And you notice that most of the red dots are on the other side of the bay. So when you notice that kind of a data pattern, that just starts to help you use data to rank and surface up more relevant jobs for job seekers. Now, this by no means is a powerful application of AI. I'm just making it easy for people to understand that every single person in this room can use AI with the data that they have in their systems right now. They don't have to wait for those gizmo algorithms to come and show up.
Of course, they might want a job as one of the ferry operators, in which case they're not going to get that through there. But you know, it's interesting to me what you've been doing in terms of artificial intelligence, also on the job seekers side.
Mm-hmm.
You know, tell us how that has affected things like personalization, driving the right job to the right person, and you know, we should give out some of you know, some of the return on investment statistics that you have, and you know, the power of that in terms of what that's done for you, but also what it's doing for everybody that's seeking a job.
It's very important what you just described. I mean, look, everything that we do, AI is in the service of helping a job seeker get the best job they can. Otherwise, it's meaningless. I mean, just a technology for the heck of building a technology is not going to be very helpful for anyone. So I'll give you a simple example. I mentioned natural language processing in the resume realm, where software wizard gets translated into something that's a meaningful job title for any recruiter. Let's take this job description. Again, I'll start with a personal story. My wife works in one of the technology companies represented here, the larger ones, and she was looking for a job. Just see what it is out there. Is there anything interesting that she can look at? She's in finance. So she goes through, looks at this other company's job, and reads through it, and then emails me and says, you know, you sent me all these job descriptions in the past like couple of weeks for me to look at. I looked at this job description. I don't think I can ever get this job. There's so many different requirements. There's so much content here. I can't even figure out how I can ever meet those requirements. I email one of my friends in that company and say, hey, you know what? My wife is this person, blah, blah, blah. This is her resume. This is what she has done. Within 5 minutes, normally it doesn't happen that fast. My friends are my good friends, but they don't reply in 5 minutes. And then this friend, she responds back. And she says, absolutely. I mean, she's a great fit for this job. I want to hire her. Can I talk to her right now? The reason for sharing that is very simple. Job descriptions have not changed in the last 30 years. Fundamentally, it's the same print ad that used to exist that has moved over into the world of internet and hasn't evolved. This is a first attempt at a machine taking a job description, analyzing it, understanding the patterns around it, and using a variety of AI techniques, including neural networks and deep learning, which is actually the facet of neural networks, you're certainly starting to figure out what are the core requirements for this job and highlighting that. So when I come in and I'm a job seeker, I'm looking for a job. Obviously, I've gotten the jobs that I look at. I suddenly get into a job description. And it says, hey, your resume is a match. So we have tons and tons of data about a job seeker, including 450 million salary data points that actually enable us to understand whether this job will have a good salary match with the salary that you have. whether your resume is a good match, whether the interactions that you have had in the past lend yourself to be a good fit for this job. But ultimately, it has to lead to a hire.
Right.
So when you get in and see this, and this resume is a match for you, you apply to this, our metric is not just whether you found it useful, whether an employer found it useful as well, and whether the employer enabled an employer to respond back to you or not. So with this experiment, it's still running. And everything at Indeed, we just run it as experiments. That's how we run the company. This experiment is running, and we found that there is a 10% improvement in quality of apply, meaning employers responding back based on job seekers applying to these jobs across all verticals. In tech, where we actually also used the previous example, by parsing the job descriptions, we started producing tags that says this job requires 3 years of Java experience or 2 years of Python experience, which is easier in tech because it's much more structured data in that unstructured world. You certainly get 15% improvement. And we're just beginning to see this. That, to you, is just a simple example of ROI.
And 10%, when you're dealing with the numbers that you're dealing with, is actually quite significant.
That's very true. We've been doing this for the last 10 years, and quite frankly, the numbers are the base for us. If we can improve something by 1%, that's a huge win. The engineer or the product manager just gets super excited if we can move things by 1 or 2%. So a 10% or 15% improvement is an incredible improvement, something that probably would have taken us 6 to 12 months in the past.
Where else has machine learning and artificial intelligence had a significant impact, maybe even more than 10%?
I would give you an example of ranking and relevance that just happened to be something that we've been working on. That has improved dramatically, like it has 2x'd in the last year, based on, again, simple applications of deep learning that we have been using over the last year. Another example is fraud. So from our perspective, if you think about it, personalizing the experience, making it deeper and richer, that's all great. But when you go into the next step, when you think about the jobs that people are applying to, are these the right jobs? Mm-hmm. Are these jobs actually real jobs? How do you know they're real jobs? And that's a real hard problem. I mean, we have 20 million jobs on our site. We have as many jobs that are not on the site. And that's a really, really hard problem. It's an operations problem. It's a machine learning problem. Most machine learning problems have an operation component to it that people often forget to mention. So in this case, once you classify a job as not a great job, like an employer comes in, it's like credit card fraud. You have to think about whether this particular incident is a good incident or a bad incident, because you don't want good employers to be penalized. So how do you make sure that a good employer, a small mom and pop coffee shop or a small doctor's office that's hiring a medical assistant or hiring a server, how do you make sure that that particular person, that particular job is a legitimate job? Whereas there are many, many bad actors out there on the internet who are using lots and lots of very interesting techniques. It's a cat and mouse game. We can probably spend the next 20 minutes just talking about that. And we have found dramatic improvements in our fraud capabilities to the point where there's an exponential decrease in fraud on Indeed because of the techniques that we've been using.
And what are some of those techniques? I mean, is that, again, an application of natural language processing?
Not always. Certainly, sometimes it's natural language processing. But even, quite frankly, techniques like logistic regression have deep impact. Quite frankly, fraud is a classification problem. At the core, I mean, you're first using unsupervised learning, and then you're using supervised learning. So you're using a variety of techniques. It's an ensemble of algorithms that you're using at the end of the day to ultimately get to that problem. But if we get to that world where what Jeff was mentioning, that you can actually 100x the power through the compute techniques that they're using, maybe you can just use deep learning by its own.
To get to this point, obviously, Indeed has been around a long time. You have all of this unstructured data. It must have been a real pain. I remember my old ETL days, back in the ERP world, if anyone remembers those things. And it was an absolute nightmare just looking at the data and getting one view of the customer. In your case, you have two different qualifications of customer. How do people resolve that? How did you resolve it? What were some of the missteps that you made along the way? Maybe what were some of the things that really kicked you as well?
I mean, there's a simple word that everyone in this room probably will agree with. I'm just making a presumption. Humility is the second word of AI. You're actually going to use all your algorithms. You're going to predict results, and those results are not always going to match. And quite frankly, I mean, I'll give you a couple of very different examples and then go into the ETL example. But let's take salary, for example, right? Very sensitive data for many people. And they obviously don't want to always share it publicly, but they are happy to share it to a machine and to understand what they might be making in the future based on the data point that we get from them. So I mentioned that we have 450 million salary data points, more salary data points than pretty much anyone else in the world, which we have gathered from extracting data that exists in job descriptions. Government jobs have that. There are other sources that we can extract it from. There's also job seekers giving us that data. Once we get that data, what do we do with it? So if I'm a job seeker that comes in, we can predict for certain jobs, not every single job, but for certain jobs, for certain job titles, we can predict with a very high degree of accuracy what the salary range for that job would look like. We thought that would be a good thing to share with the rest of the world. So we did that. And certainly we saw pretty good impact with job seekers. They were clicking on more jobs. They were essentially using that to decide whether to apply for that job or not. But certainly our call volume in our call center, just in our customer service, just literally went up 2x, 3x in a couple of weeks. Employers were calling us saying, we don't want that data to show up. In many cases, they were saying, actually, we want to pay more. What you're predicting is not, you're predicting the normal range for what we pay for that particular job title. We want to pay you more. And so we had to take a step back. I said every machine learning problem is also, in many cases, an operations problem, a customer service problem in some cases. So we had to actually take that bow and really decide that, hey, you know what? We have to give the employers an opportunity to correct salary ranges when we show this. That's an example of a misstep, as well as a great learning for us.
Yeah, perfect. I want to make sure we get any questions answered in the audience. If you have a question, then maybe put your hand up. We're going to run a microphone out to you so that we can hear your wonderful voice. The microphone is on its way.
Hello. This is Sid. I'm a chief scientist at Conversica. We develop conversational AI, but more for sales. So my question is from the perspective of where do you see recruiting happening more in like 10 years or 20 years? Do you still think a lot of the data will be in websites, or do you envision a lot of interactions happening over conversations? So do you have any thoughts on?
Somebody in this room will say you are my plug, literally, because I was flipping to the side where I was going to talk a little bit about conversations. But Sid, let me just bring forward Indeed assessments. So there's this company called Interviewed, a Y Combinator company that we acquired a few months back. And the whole premise of Interviewed is resume is a one-dimensional view of any candidate. And in the new world, just like job descriptions haven't changed, resumes haven't changed, how do you actually assess someone in a different way than they have been assessed in the past? So we have been using Interviewed in a variety of ways to actually determine how conversational AI can be used to find out how a candidate would be a much better fit for a particular job or not through work sample tests. So a customer service agent, their main job is to service a customer. So we used a European call center where they had literally they had to be trained in 7 different languages for answering calls. And they were using language specialists to train these people and do the interviews. Thousands of applications going through language specialists, scheduling that, making that work, really hard for job seekers and employers. And also false prone. When they used, quite frankly, the Interviewed assessments or the Indeed assessments, they saw a significant improvement in both the quality of the hire that they got as well as the time to hire that they experienced. So again, using some of the techniques, and we can go into it offline. I'm running short on time, so I'll just literally leave it at that and have a conversation with you offline on conversational AI.
If we've got time, we can have one more question very quickly, but you've got to make it like a tweet, not a 280-character one either. Anybody? No. In that case, you can always. Did you have the dash button?
I do.
We should put that up. That's what it really should be like. That's the future of job seeking right there, right?
So I'll leave you with this thought. I think the recruiting world will dramatically change. It will just, I think everybody in this room has and had an experience in recruiting in some fashion. And quite frankly, what we expect in the next decade or so, to get to the point where a job seeker would wake up in the morning, they'd click on a button, and that would help them realize whether their salary range is the right salary range or not, would help them decide what their next opportunity is. And the whole fundamental premise is not to replace human beings, but to augment human beings with the technology and solutions that enable recruiting to be a less pain in the ass, frankly.
Fantastic. Raj, thank you for being an augmented human being. Please give him a round of applause.
Thank you. Thank you.
Fantastic. Thank you, Raj. Now, we are going to welcome to the stage Rajat Mishra, VP of Worldwide Services Strategy at Cisco Services, talking about Cisco's journey to predictive services, 3 lessons from Hollywood. After Rajat has been on stage, he will be joined by Jaina Eggers, and Jaina will be asking Rajat questions. So please, for now, please welcome Rajat Mishra.
Good afternoon. Good afternoon. Now, when Matt Marshall and I talked about speaking at the VentureBeat Summit, he told me about this distinguished audience. He told me about all the great speakers that'll speak before me and all the amazing topics. And when he said that, the first question that went through my mind was, what can I say to keep this audience interested? And then Matt told me I would be speaking at 4:55 p.m. in the evening. The last speaker between the audience and drinks. And the second question that came to my mind was, what can I say to keep this audience interested? So today, I wanted to speak from a place of humility and a place of vulnerability. I wanted to talk about 3 lessons we have learned in the last 3 years in our journey to Cisco Predictive Services. Now, these are lessons we have learned in the School of Hard Knocks. They are not glamorous, but they are real. They don't look pretty, but they are honest. And I hope at the end of this discussion, these 3 lessons give you something to think about as you go on your ML and your AI journeys. Oh, and by the way, I have always loved the movies, so I'll express these 3 lessons in movie metaphors. So lesson number 1 is about the man-machine continuum. When we started this journey 3 years ago, we argued a lot. We argued a lot about what the final form of Cisco Predictive Services would look like. And when we dug deeper, we found out it really wasn't about the form of Cisco Predictive Services. It was really about that we as an executive team differed fundamentally in what we thought man-machine interactions would look like in the future. There were some of us who thought machines would dominate, and people would really not have a role in the future of services. There were some of us who thought, hey, people will always remain our strongest asset, and machines at best would supplement them. And there were some in the middle who thought man-machine, woman-machine would play together. Now, the real question for us was not what should be the form of Cisco Predictive Services. The real question, the real fundamental underlying question for us was where on the man-machine continuum should our business stand? Now, the movie Iron Man provides an apt metaphor to think through this problem. For those who know the movie, it's about Tony Stark, a brilliant engineer who develops a powered exoskeleton. Now, Tony Stark himself is brilliant and great. The powered exoskeleton is wicked cool. But it's only when Tony Stark and the exoskeleton come together, it creates Iron Man, the amazing superhero that my 6-year-old son loves and really wanted to be this Halloween. So we took a page out of Iron Man, and we thought really deeply about our business, our customers, and our strategy. And we thought about where on this man-machine continuum we should play. And what we quickly realized was that our people are our Tony Starks. Our people are expert simplifiers, expert optimizers, expert implementers, and expert advisors. Cisco Services customers love our people. We realized that the human connection would always be important. So we set the goal to the man-machine question at 30-70. 30% of our solution would always be human, and we would make the humans better and help them do more and become more through AI. Now, the lesson for us was not the exact solution of 30-70. The lesson for us was to unearth an underlying assumption about where we should play on the man-machine continuum and think about, for our business, for our strategy, and for our customers, what is the right answer. Lesson number 2. When we started our journey, much like many large companies out there, we did not start greenfield. There were many competing initiatives in play. And there is so much hype about machine learning, it felt like people were not starting with problems and trying to figure out how to use machine learning to solve them. It felt like machine learning was a hammer, and people were looking for nails to hit this hammer with. So amidst all this noise and hype, as a business, which initiatives to focus on, which ones to nurture, and which ones to grow? That was the question in front of us. Now, Michael Lewis's movie, Moneyball, is a great metaphor to think about this question. For those who know this movie, it's about Billy Beane, the general manager of Oakland A's, the Oakland Athletics, not very far from where we're standing here in Berkeley. And Billy Beane defied tradition. When other general managers of baseball teams tried to identify stars by looking at what do they look like, what do they feel like, he looked where no one else looked. He looked at statistics that no one else looked at. He looked at people that no one else looked at. Inspired by Moneyball, we said we must defy tradition if we have to find out the right initiatives for Cisco. So no longer did the hotshot executives program become a shoo-in. No longer the brilliant data scientist program would be something we would do definitely. We looked everywhere. And what we found, a small group of engineers in Switzerland, one of them is in the audience here today, they had developed a solution called Big Data Broker Borg, or BDB Borg. Clearly, not a marketing name, an engineering name. Right? And what they did, they had digitized our intellectual capital. Cisco has 6 million customer interactions every day. They had digitized that intellectual capital, and the problems that took days and weeks to solve, now we could solve it in minutes. We, as an executive team, doubled down on BDB Borg. Today, I'm very proud to say BDB Borg has over 17,000 modules. It continues to learn. For every customer case that comes in, there's an 86% chance that Borg will find the underlying issue. And Borg has won the highest accolade for innovation in Cisco, the Pioneer Award. The lesson for us here is to defy conventional wisdom, take a first principles approach to find the next best machine learning initiative. Great innovation, my friends, is already happening at the grassroots. All you have to do is look. The third lesson was about the data analytics platform. Now, Jeremy talked about this. We also talked about this in the Autodesk session. Now, when we started, we had several initiatives in silos. They had a good set of data. They were doing a good set of analytics. And they were deriving a good set of results. Now, we wondered, what if we could look at all the data in the organization and build algorithms on top of it? Could we create richer insights for our customers? Now, Steven Spielberg's Minority Report provides inspiration to think about this problem. The Minority Report is about the future, a future where police has a division called pre-crime. They find crimes before they occur, and they fix them before those crimes can occur. Pre-crime is powered by 3 psychics called precogs. Now, these psychics, they have visions. Think of them as the data you need for machine learning algorithms. And interpreting this data, you can come up with insights for who the perpetrators would be. Now, each of these precogs, their insights are great. But when you put the 3 precogs together, literally in a floating platform, like Steven Spielberg did, the accuracy of pre-crime increased, and the false positives went down. So inspired by Minority Report, we went silo busting. And for all of you who work in large organizations, you know it is very, very, very hard to do. Right? So the first thing we did, we found one willing group. And we asked them, hey, would you be interested in a little bit more data to come up with an insight that's a little richer? The second thing we did, we needed an objective opinion. So we asked our distinguished engineers to come up with an objective point of view. And they came up with an objective point of view that talked about the benefits of the common platform and the insights we could gather. And finally, we had to do some top-down direction setting also. So we had our wonderful head of Cisco Services, Joe Cozzolino, send out an edict that thou shalt do this. Now, through a combination of those three factors, we've gotten most of the data together in one platform. And the insights we get from this platform are far richer than others. The lesson we learned from this episode was that getting data together into one platform is hard. And getting analytics on top of it is even harder. And there were times when I was sitting in my office over the last 3 years where I almost gave up. But the fight for combining data and creating one data analytics platform is worth it. Don't give up. Don't give in. Now, these three lessons lie at the heart of Cisco Predictive Services. Not to market our services, but there are many people here in the audience and many people listening to it on the live stream. I'm very proud of this team. For example, at a national bank, we could identify a network outage 32 hours before that outage occurs, and in 1 hour, we could fix that outage. Just think about what does 1 hour of network down mean for a national bank, and you can appreciate the CSAT impact we've had with this initiative on the client. With a service provider, we've been able to automate 99.9% of software changes. And 20% of the issues that come in are because of faulty software changes. So this has driven CSAT and driven up revenue. Now, we started this journey 3 years ago. But our journey is not done. We continue to push hard. We continue to make mistakes. And we continue to learn more lessons. But as my favorite quote is what Tony Stark told his AI assistant, Jarvis. Sometimes you got to run before you can walk. Thank you.
So Rajat and I decided that we would stand, mainly so we could run faster than you guys to get out to the drinks, but also so you knew we weren't settling in for the long haul. So Rajat, thank you for a great presentation, and also congratulations. You've just been named your alma mater's 40 under 40, so
thank you.
Those are great achievements.
Thank you.
So you mentioned Jeremy brought up this centralizing the data platform, and it's something we see with our clients all the time. The data silos are a major problem. Another thing we see is once they break down those silos, the data is very different. It may be quality problems. It may be the depth of data. You heard Jeff Dean bringing up, how much data do you need? And sometimes you have millions of data points, and sometimes you have 10,000. Both should be used. How did you all think about that, the data quality between silos as well as the data amount between silos? And how do you bring those together? Maybe it's a baby cog, a baby precog, and an experienced precog.
Yeah, sorry, it's a little hard to light. No, but Jana, I hope I could tell you that we had a very analytical approach to this problem. I wish I could have told you that we categorized all our data, we had a multi-factor algorithm, and we said what we'll move in first, what second, and third, and we implemented that approach. I could tell you that, but that would not be the truth. Right? The truth is much messier. And I promised in the beginning of my talk that I'll be honest and I'll keep it real. So instead of focusing on data, we actually focused on the people, Jana. And we found one small group in our business who was willing to work with this new approach. And they were willing to take in a little bit more data, try a different analytics approach, and get a better result. So we started with them, and we used their data set. Then the second thing we did, we went to a few execs who we thought would be more open and receptive to this approach. Right? Again, not the data, but the people. And this exec said, hey, you know what? I'm not getting the results I want anyway. I'll try it out. So what started with this small group and what started with this one exec created a mini snowball effect. And other people started seeing, look, the results are better. So they started sharing their data with us. And that led to data being shared more. And let me tell you this, we still have a few data sets that still aren't fully integrated into our solution, but that's the process we followed. And I remember when I was going through this with the team, there were times, Jana, where I was very, very uncomfortable and unsure about where we're going to land. But I think someone said that doubt is an unpleasant condition, but certainty is an absurd one.
Well, so you're being both honest and consistent because, as you said, you've got to walk before you run. And this is something that we tell our customers, too, is don't get so obsessed with this data, doesn't match this data in terms of depth. Really know what tools you're using for each and bring them together. So thank you for that great example. So I'm going to switch up the questions we talked about a little bit before, but it's really based on what you just said, which is how much effort you put in to the team. And one of the things that you mentioned with the Moneyball example was the grassroots effort and finding in the grassroots. How do you get them to feel confident that they can do AI? Because our customers will often say, we don't have enough AI experts. And I always tell them, you don't need experts. You need people that know your business. Yeah. So how do you get them inspired to do those?
Yeah. I'll steal a quote from my wife. My wife runs her own machine learning startup. And she tells me, she has a small team of 20 people. And she says that every person needs to feel like a superstar in the company. Every person needs to feel like a superstar in the company, and it's a leadership's job to make sure people kind of do so. So we try to make sure that we celebrate everyone's success. And at Cisco, we have a very consistent way of looking at assets because we are a very acquisitive company. Our approach is the build, buy, and retain. And that's the approach we've actually adopted for AI. So in the building, we have tons of training programs that we use. Many of our engineers were trained in the pre-ML era. And there's probably some companies out there which also face a similar issue. But what we've learned as these hardware network engineers, if you train them, a significant portion can learn R, can learn Python, can become AI engineers. So that's kind of one bit of build. Buy, we are pretty acquisitive. Last week, we bought Perspica, machine learning company. A few months before that, we bought MindMeld to bring in that AI talent. We also recruit from colleges both locally and across the country. So that's the buy piece of it. And finally, retain, which is a hard problem in the current scenario for AI. So I think the problem with AI is not that people don't understand and are not excited about it. The problem is people come into companies and they end up doing science projects, not real things that lead to real impact. So what we've tried to do, we have an Innovate Everywhere challenge where there's one exec who's a sponsor of every project. And we make sure that the projects these people work on, they lead to real impact and real ROI.
That's great. So I'm going to ask one more question, but that's your cue to think of your questions because we'll go to the audience next. So my next question is, you talked about there being disagreements across the organization about where the man-machine continuum, where you should land in that. How do you, once that decision's made, get alignment? Because AI is often so amorphous that we see people sort of feeling like, well, yeah, we decided 70-30, but really 30-70 is going to be where we end up. And so you don't have people quite as aligned because there's so much more squish with AI. So how did you guys get alignment in the organization about what you were really going for and constantly driving to get there?
So Jana, one of my beliefs is that extraordinary happens at the intersection of unlikely things, right? I firmly believe that. And for this one, we adopted a similar approach. We said it has to be analytical from what customers are saying, and it has to be philosophical based on what the soul of Cisco Services is. So analytically, our customers told us for network outages, they are not ready for auto remediation. They're not ready for a machine to come and tell them what fix to put on their network, which is going to govern hundreds and thousands of devices. So that was what we're hearing from customers. And we thought a lot about what the soul of Cisco is. And like I said, our engineers are our Robert Downing Jr.'s, are our Tony Starks. And the soul of our business, Cisco Services, is our people. So we said we have to have a certain amount of people component in our business. So that's how, because of the analytical and philosophical, we are grounded at that 30-70, and we won't let the people component go down below 30%, at least as of now.
That's great. So any questions in the audience? We have one back here.
So I'm going to stand here with the lights coming on. Yeah.
So following on your analogy of Minority Report, the way the movie ends is with misprediction. What has been your experience with misprediction in this predictive world, and how significant or lesser has the impact been?
Yeah, great. You know, I'll just share another anecdote. Is even the book, right? Minority Report is based. Apart from Moneyball, Minority Report is based on a story written by Philip Dick in 1956. And there, the Tom Cruise character is a 50-year-old, balding, kind of heavy-set person, not Tom Cruise. And also the story ends with the Tom Cruise character actually going to jail. And but Hollywood has kind of has taken some liberty with it. But the answer to your question is we do make several mispredictions now. And like the other speakers have talked about, as our data set improves and as our people improve, we're able to refine those algorithms. Like in the service provider example we showed you, in the first few months, our error rate was pretty high. And now with every week, that's going down. Our engineer from Switzerland, he just sent me an email last night that in the first revision of our work with our client, the error rates were pretty high. In the last revision, Fabi, 61 out of 61, our score has been 61 out of 61 in terms of predicting things correctly, right? So I think the errors are a part of living in the machine learning world. But if you stick with it, stick with data, and have the right processes, they will improve.
Y'all up for one more question? One right here.
Speak loudly.
We can repeat it too.
I'm Jameson from Orange, and we're a big Cisco partner. So understanding the critical nature of data to do machine learning, what's your take on creating ecosystems with service providers and sharing data bidirectionally so that we can better serve our customers' needs?
Yeah. So it's, the honest answer is a tricky topic, right? So what we've been trying to stratify our data. So there are some core sets of data that are core IC. For example, what are the data sets we're getting from customers on customer problems? So we are keeping that in-house. Right? However, when we work on these data sets and create transforms that could help solve these problems, those are some data sets where we are sharing with our partners. Right? So we are investing significantly in open sourcing, and you'll hear a few more announcements in Cisco Live and the other events. But we're moving to a place where we keep some parts of the data that need to be in-house, but use other parts of the data with our partners, and together go to market with them. Like business critical services is one of the services we launched last week. It has a big component of working with partners to move to solutions for our customers. And I'm happy to talk a lot more about it because a lot of Cisco revenue goes through partners.
I think we'll call time now because I know the conference is running a bit over, and as we said, we have drinks next. So Stuart's going to come back out here? Yes? Excellent.
Thank you.
Thanks.
Thanks, Dan. Thanks so much. Thank you. Awesome, thank you so much. We are now going to close for today, but before we do that, and before we let you out into the wild, we have just a couple of little announcements. First one is, those people who have been invited, you know who you are, especially invited to the retail and e-commerce dinner. Remember, you're going to the alumni room. Everybody else, you're still special. We love you very much. Don't feel bad that you haven't been invited to that. We want you to go, thanks to WorldPay, to the reception, which you will find in the restaurant over on the right-hand side of the hotel when you leave this area. That has been the program for today. Of course, it doesn't stop now. You get to go and eat, and you get to go and talk and cogitate on everything you've seen. Thank you so much for a wonderful first day of VB Summit, and we'll see you later. Thank you.